right. Thanks, Dirk, for the nice introduction, and thanks for the invitation. So my talk is entitled The Bodily Self in Neurotypical and Neurodiverse Populations. And if we want to address this question, of course, we have to first ask, what is the self? Of course, now I could probably talk this whole time only about this question, but then we don't ever get to all the interesting data. So we have to kind of skip through this, and you just got to stay with me and my definition that I'm using here. So I like to go with this guy here, William James, who was a psychologist and philosophist, and he suggested that the self has several layers. It's kind of a hierarchical, multi-layered structure, which of course also others have suggested, where the bodily self forms the basis of the higher order aspects of the self, like reflective and social self, or also then at a higher level, the spiritual self. However, I would actually argue that the social self belongs down here. The bodily self is already inherently social. Why would I say something like that? Well, the bodily self, a very important aspect of the bodily self is self-other distinction. And a self-other distinction, together with also other aspects like interoception, proprioception, sense of agency, contribute to this basic experience of self. And self-other distinction is something that we first experience through touch. And that is through touch, not just only touch to the own body and to the self, but also touch to the outside world. But this develops already in utero, so this has happened to all of us in utero. We were little embryos in our mother's bodies, in our mother's wombs, and we would touch ourselves, and then we would touch the outside world. But the outside world is another human being, right? It's the mother's body. So this is inherently social. There are studies that have looked at this, and they see that if you have one baby and you look at them in the ultrasound, you can see that they have goal-directed movements towards their own body. They touch themselves. And sometimes you have two babies. You can have twins. This is what we see here. This is one baby. This is the other one. And they also see that the twins actually show goal-directed movement where they touch the other twin. So also here we can see this is a very early social behavior, actually. And this is first experienced through touch, which is the primary sense that develops already in utero to allow us to have these experiences. Of course, after being born, babies interact to touch also with their caregivers and the world around them. And again, touch is the most important first sense for this. We're not really good at seeing or hearing in the very first couple of days or weeks, but the tactile sense is already fully developed. So these early interactions lay the ground for also a very healthy development if there's enough touch during early life. There are two important sides to the medal. So on one hand, it's very important that we have self-other distinction, that we know this is me, this is my own body, and this is the outside world, these are the others, this is not the self. But at the same time, it is also important that we have some kind of self-other merging, or the ability to do self-other merging. We need this for connection with other people, for building trust, for experiencing empathy, for experiencing love. And the tactile sense can really do both of these things. It can mediate self-other distinction, and it can mediate self-other merging. So because of that, I think the sense of touch is a really good, important sense to use to understand the sense of self. So how do we do this? How can we use the sense of touch experimentally to understand our sense of self? This is what we do in my lab. Here you can see me putting a participant in the MRI scanner. We use fMRI in the lab. And we do a very simple task. So we just ask people to either touch themselves or receive touch from somebody else. Or we have a control condition where they just touch an object. So doing self-touch, they just use kind of like nice, slow stroking on the arm. And then doing other touch, we do exactly the same thing. And then, of course, during self-touch, you have movement, so we have to be able to kind of take that out. And for that, we use the object touch condition where they just do the same kind of movement on a skin-like pillow next to the arm. what do we see when we look what happens in the brain during these different conditions? In neurotypical participants, when we look at in which areas do we have more activity in the brain for other touch compared to self-touch, what we see is a lot of areas. So we see, for example, somatosensory cortex, primary somatosensory cortex, but we see also prefrontal areas. We see the temporoparietal junction, which is important for theory of mind. We see the whole temporal sulcus down here, and even subcortical areas like the striatum. And also very importantly, the insula over here, which is very important for perceiving our own body. So these areas all show more activity for other touch than for self-touch. This is in part driven by activity that we get from other touch. So here you can see in yellow and in red areas where we have activation during touch from others. And then in kind of green, bluish, up here, you can see some areas where we have deactivation. But then what happens during self-touch? During self-touch, we actually have a lot of deactivations. So what you can see here is that we only have a little blob up here that shows activations, which is related to the moving hand, the motor activity, while we have actually no activation at all on the other side, which is the area that receives the tactile input. And we have a lot of deactivation all over the brain. So I was interested in exploring this, just looking a little bit more in detail and specific areas that are that we know are important in the processing of tactile stimuli, or specifically slow affective touch. So we just looked at certain regions of interest for these 3 different conditions. So what you can see here is in blue is the being touched condition, and in green you see self-touch. And we looked here at the anterior and posterior insula. And we also see somatosensory cortex, left and right. Does it beep a little bit? I can see here feedback maybe from this. I don't know, I can hear feedback from myself. Okay, if it doesn't bother you, then I can just ignore it. It's fine.
We don't hear.
Okay, then it's just in my head. Great. Okay. Maybe this one will be better. I don't know. So you have a lot of activity here in the left somatosensory cortex, which is just related to the right touching hand. But you can see deactivations for self-touch in all the other conditions. And then even if you look at these very early processing areas, like the thalamus or the brainstem, you can see that even here during self-touch, we have a certain level of deactivation. Now, I was interested in seeing if this is something that, let's see, go even deeper. So what we did was a very complicated setup where we looked at the brain and the spinal cord at the same time during this task. And what we see is that here you have the spinal cord. This is what an fMRI from the spinal cord looks like. Of course, the spinal cord is not that straight in real life, but you have to make it straight for the analysis. And this is C5, C4, this is kind of this area here where the nerves from the arm, from the dermatome, enter the spinal cord. And here you can see kind of a slice right through here. And what you can see is this area where we have a main effect. So in this area of the spinal cord, you can see that we have activation during other touch. So this area is responsible for the arm being touched. But we have no similar comparable activation during the self-touch condition. So already in the spinal cord, we see this kind of deactivation that we also observe in the brain. Does the spinal cord know that we're touching ourselves and remove the signal? Probably not, right? Probably what happens is that there's actually some kind of top-down signal that goes into the spinal cord from the brain and tells the spinal cord, this is not relevant, this is not so important. You don't have to respond as much to this incoming signal from the somatosensory neurons in the arm. This is following probably everybody knows this idea, the idea of the afferents copy. So the idea is that we have a motor command coming in. The motor command sense out a motor signal, and then we touch ourselves. It creates an actual sensory outcome. But at the same time, there's some kind of prediction being created when we send out this motor command, which is called the efference copy. Still, nobody has really found the efference copy in the brain, but that's the idea that originated from Helmholtz already, the idea that there has to be some kind of prediction, basically, about the sensory outcome of this action. And then these two are compared. And if they match, not much happens. If they do not match, we have a prediction error, and this prediction error can be used to update our internal model and future efference copies. And now, of course, self-touch is the perfect kind of stimulus or behavior that can train this here model for the self model, for predictions about the self. Because doing self-touch, we have the perfect prediction, we have a perfect closed loop, right? Like I know exactly what I'm doing this, I can predict this, and then the signal can go right into my brain and can create this perfect model of the prediction of the sensory outcome. So self-touch seems to be especially important for developing kind of a model of the own body, and in a way maybe of also the higher order of the sense of self. Okay, so does this then actually, the self-other distinction that we see, relate to any higher order aspects of the sense of self? In this first study, what we did was that we just had a very basic questionnaire. So it was a self-report. We asked people about a very high-level aspect of the self, self-concept clarity. How sure are they what kind of person they are? And we looked at different areas where we know these are related to self-processing, like the anterior and posterior insula and the anterior cingulate cortex. And we found correlations in all these areas with this difference between self and other touch. So people who had a larger difference between when they touch themselves or are being touched from somebody else in brain activity, they also were more sure about what kind of person they are. That's pretty cool already, but of course, it's just a correlation, it's just a self-report, so yeah, we have to go a little bit deeper. So there's other ways how we can try to answer this question. And one that I thought could work is to look at what happens to self-other distinction when the sense of self is altered. One way how we can do this is to pharmacologically alter the sense of self. So for example, we can use ketamine that can cause dissociative experiences. Another way is to try to look at conditions where we have an altered sense of self, like, for example, schizophrenia. So we'll first look at this first study here where we did this. We had people come to the lab 2 times. One time they received ketamine, one time they received a placebo during fMRI, where they were doing the self-other touch task. Then we had a clinical interview to see how much dissociation experiences they had, and then we measured their thresholds, and there were some other self-report measures. The thresholds are important because ketamine is typically used as an anesthetic, and of course, if we do a touch task, we have to make sure that they actually feel this in a normal way. But we did not find any difference in tactile thresholds during ketamine. Now, if we look at the brain, we see first the placebo condition that we can replicate what we found before, the difference between self and other touch. And then during the ketamine condition, you can see that it looks kind of similar, but it's a little bit weaker, right? But now what we are most interested in is there any kind of interaction? And there is. So in this area here, that is kind of bluish, in this really interesting cluster, we find an interaction effect for ketamine and placebo and other and self-touch that you can see plotted over here. So in this area, during the placebo session, we have a big difference between other touch and self-touch. And then in the ketamine condition, it becomes smaller. And this is kind of a cool, interesting area because this is not primary somatosensory cortex. It's not just that they don't feel it as well or anything like that. This is kind of an area that touches upon the secondary somatosensory cortex, but then also touches upon the TPJ. It also kind of extends into the posterior insula and the superior temporal sulcus. Does it relate to much they have dissociated. For that, we did a connectivity analysis where we looked at how this area connects with somatosensory cortex, and we find that that was actually correlated with how much they dissociated in this clinician-rated scale. So this is some support for the idea that there's a connection between this very basic tactile self-other distinction and the higher order sense of self. Now we move on to the next study where we looked at schizophrenia. First, a little bit of an overview about schizophrenia. Typically, schizophrenia is described as having 3 different types of symptoms: positive symptoms, negative, and cognitive. Positive symptoms are not called positive symptoms because it's something good, but because something is added on top of the normal experience, like hallucinations and delusions. Negative symptoms are something like anhedonia or avolition, so not enjoying things and not wanting to do things. And then we have cognitive symptoms like impaired executive function, thought disruption, and disorganized speech. This is kind of the textbook description of schizophrenia, but schizophrenia has also been discussed a lot as a self-disorder. And that is because it has aspects of depersonalization, it has experiences of derealization, a diminished sense of existing as an embodied, coherent subject, and of being the author of one's own actions, so reduced sense of agency. There are 2 kind of forms or types of altered self-processing in schizophrenia. There's heightened self-referential thinking, so everything's directed at me. So if somebody is sitting in a bus and people are looking around, and the person with schizophrenia will perceive this as like everyone's just looking at me, and this can form the basis, for example, for paranoid delusions, where you think like everyone's following me, they're all looking at me, something has to do with me, or also something like the idea that like the news are directed just to me, like they're trying to send me a message, yeah? And there's also reduced self-other differentiation, so a wrong attribution of self-produced perceptions to an external source. The most basic example would be the own thoughts in someone's head being interpreted as not being the own thoughts, so as like a voice that you hear, or maybe also that they are being controlled by some kind of external force or being put into you by an external force. Also, very often there are these experiences where patients report that they feel like they're being controlled by some kind of external force. Like I know we had this one patient who felt that there's some kind of demon behind him who's like controlling how he moves. So not being able to attribute your movements or experiences to yourself. Of course, I'm not the first one who thought to test the self-other distinction in schizophrenia. A very classic paper is the one by Sarah Blakemore from the 2000s, where they also looked at self-other distinction in this very basic task where they had this little machine, and there's a pin here that kind of tickles the palm of the hand. And either the subject can move this or the experimenter can move this. And all they did was just ask them, how ticklish does this feel? And they find that now what you can see here is the difference in rating between other and self. So normal controlled subjects feel like that it is more ticklish when someone else moves it compared to when they move it themselves, not that surprising. And patients who currently had symptoms, they did not show this difference. It's often reported as schizophrenia patients can tickle themselves, which I don't actually think is true. It's not like they can do this and then laugh a lot. I don't think that. It's just, they just ask how ticklish does it feel. I think it shouldn't be overinterpreted. So in our study, what we did is that we had 35 patients and 35 age and sex matched controls. And they came for a first visit where they met a clinician who did a clinical rating, the BPRS score, to evaluate their symptomatology. Then they came for a second visit where we did some neuroimaging and again the touch task. And they came for another visit where we did also some EEG and somatosensory evoked potential measurements. We also did some interoception, heartbeat detection task. I'll explain this in a bit. And we also measured thresholds. I'll explain this also later. So first, let's look at the fMRI. Psychosis patients versus controls. At the whole brain level, we find the main effect of group. So we have a higher activation in these areas that you can see here. for the patients compared to the controls for both touch conditions, for self and for other touch. And again, you can maybe, if you remember the ketamine study, look at this and see that this looks kind of a very similar region as the effect we had in the ketamine study. So now if we look in detail for self-touch, we find that there is more activation in this area here, which is kind of the superior temporal gyrus or sulcus. And for other touch, we also find more activity in kind of a very just adjacent area to this, but it's more, it's actually, this was an exploratory analysis, so here we actually use the ketamine cluster as a region of interest and find that in this region, they have more activity when someone else is touching them. So it's not exactly what we expected. It's not a larger difference between, a smaller difference between self and other, but what we do find is what we expected is that they have more activation during self-touch. So they fail to attenuate the self-touch, basically. We also did a very basic test looking at thresholds. And so what we do here is actually, it's a little bit of an integration question. So we stimulate them with these FAM5 filaments, these little filaments here. And they just bend, and you have to say yes when you feel it. And there's like an increasing thickness to them. And we do this at the same time, simultaneously to the different touch conditions. And before, in the neurotypicals, we found that during self-touch, we actually have an increase of this threshold during, while people are doing this, and then we do this at the simultaneous time with the simulation. Now, in the patients, we found that for them, do you see them here in black? There was no difference between self and other in the threshold, even at this very basic processing, basically. So here on the other side, you can see the difference between tactile thresholds for self and other, and you can see it's a group difference for patients versus controls. So already this very basic processing of just a change of modulation of the threshold seems to be altered. At which processing level does this occur is what we also asked. Of course, we couldn't put them in this very complicated scanner protocol for scanning the spinal cord. So what we did instead was somatosensory evoked potentials, which is kind of like EEG. You put electrodes, but not only on the head, you can also put them on the neck at the same level as we measured for the fMRI study. And what we're interested in here is this N13. So the evoked potential at the spinal cord level. And also here we find that at the spinal cord level, the patients show less of a difference between self and other compared to the controls. So also this top-down processing is potentially affected. It could be different explanations. It could also be that there's like the modulation itself somehow doesn't work within the spinal cord. It could be also that other aspects that contribute to this modulation, like the effects of the touch itself, like maybe slowing down of breathing or heart rate doesn't work. But I think that, yeah, the most probable explanation is that the top-down attenuation is not working. Then we were also interested in looking at other aspects related to the sense of self, and specifically other ways of perceiving sensations from yourself versus non-self-generated sources. And for that, we looked at interoception. Of course, there's a lot of studies that have looked at this also in schizophrenia, using vision or using the auditory sense. But I think it's very interesting to look at these senses that are very close to the body and very basic for the own body perception. So we did a heartbeat detection task where people are just supposed to press a button every time they feel their own heartbeat. And then we have a control condition where they just press a button every time they hear a heartbeat. So this is an external stimulus. And the patients can do the task, which is important. So they can follow the external stimulus, which you can see over here in blue. But they were worse at following their own heartbeat. So they were worse at perceiving also signals from within their own body. At the same time, we also measured EEG, and you can measure a heartbeat evoked potential. So every time your heart beats, you can actually measure an EEG potential in the brain. And we also found that there was a difference in this potential between the patient groups. and the control group. Now, we were interested in seeing, does this at all relate to symptomatology? So we ran a couple of different regression models, and one that was significant was looking at all the different touch-related measures that we had, and when we combined them in a model, this actually predicted the total BPRS score, so the total score for symptomatology. It also predicted negative symptoms, not positive symptoms, but positive symptoms were actually not really high in this group. Of course, you can't have somebody who's like acutely in a psychotic state and put them in an MRI scanner, right? So these patients were medicated. These patients were not very acute in this moment. So we can, just assume that maybe the negative symptoms tell us something also about the severity of positive symptoms when they're in an acute state. So this effect, all these effects that are they kind of cause this idea that schizophrenia is a self-disorder, might actually be driven by a reduced self-other distinction and a less clear interoception. So we have now some support for the association between this very low-level self-other distinction mediated by touch and high-order or high-level sense of self. One time when we temporarily alter the sense of self using ketamine, and one time when we look at a chronically altered sense of self in schizophrenia. What about other conditions where the sense of self is affected? I also have studies where I looked at ADHD, at autism, at anorexia. Why these? Well, this actually kind of comes from the observation that there's atypical touch sensitivity in all these conditions. So something that they share is sensory hyper and hyposensitivities, touch avoidance, alterations in social and emotional and self-related processes, and altered body perception and awareness. However, there are very few studies actually that have investigated this. For example, here in ADHD, very few, and these are all just questionnaire or parent report studies, nothing experimental. There's some of these studies in autism, but with very mixed findings, and also very few experimental studies actually where they looked at brain responses. Also these are, not very conclusive. There are a few more studies in anorexia that are all looking at other touch zone, not at self-touch. So they have found reduced responses in response to being brushed by kind of a soft brush on the arm, and that anorexia patients perceived this kind of soft brushing as less pleasant. So before, when I said with regard to the bodily self model, the self-touch plays an especially important role. I think it should have become clear that the self, as being like a kind of a closed loop, the self-touch, is something that could be especially interesting also in these populations, and there aren't any studies that have looked at that. So that's something that we did. We ran kind of the same task in these populations, and what we find is in ADHD, that there was stronger self and other effects. So in ADHD, we had in the insula, we had more deactivation during self-touch, while in the somatosensory cortex, we had more activation during touch from others. So it's not exactly in the same areas where we have this larger difference, but like in areas that are critically involved, we find that in one area we have more deactivation, and the other one we have more activation. Now we also wondered, is this related to symptoms? And you don't always design your studies perfectly. In this first study, we were really excited to run the study. We only did the fMRI, and we didn't actually collect any symptom measures, which was a little silly. So we did another study, but now we didn't have the money for the fMRI anymore. So now in this case, we ran the somatosensory evoked potentials again, and we find that they show, the patients with ADHD show a larger modulation of the amplitude that we measure in during the two different touch conditions compared to the controls. The NTs here are neurotypical controls. And this actually correlated with the self-reported symptom severity and touch sensitivity in this group. So we have a larger response to non-self-evoked stimuli and a larger attenuation of self-evoked stimuli, which we can maybe interpret as a larger self-other differentiation. And this might actually explain some of the sensory hypersensitivities, for example, for texture. So something that patients complain a lot about is that they're very sensitive to like the tag in their shirt, or like they don't want to eat certain foods because of the consistency, or the kids don't want to brush their teeth because it feels gross. But of course, if you have a very clear perception of this is my body and like everything else is coming from the outside, that might actually lead to being more sensitive. And it could also, I don't want to lean too far out of the window here, but it could, of course, also actually relate to like the classical symptoms of inattention and hyperactivity. Because, I mean, if you were just bothered by all these sensations that you're having and they're kind of coming into your self-perception the whole time, of course you will be inattentive, and of course you will become hyperactive if everything's scratchy and itchy and just uncomfortable, right? But I can't say this is the cause of the typical symptoms of ADHD, but maybe, I don't know. So then in anorexia and autism, we were actually interested in looking at those two conditions at the same time because it's known that there's a symptomatology overlap. And there's a co-occurrence of these two conditions that is quite higher than in the general population. So we were interested in seeing if they're similar or different regarding self-other touch processing. So we actually combined anorexia and autism participants into one analysis, also had a control group. And here we find a main effect of group in the areas that you can see here. So again, this is for both touch conditions, a main effect of group. And then we explored this in a little bit more detail in post-hoc comparisons. And here we find that this is actually driven by the anorexia group. So you can see here the anorexia group in green, and this is the autism group, and this here in yellow is the control group. And we find in the somatosensory cortex and the insula that during other touch, the anorexia group shows more activity. And during self-touch, the anorexia group also shows more activity. And what's also very interesting here is just note this is that the autism group is not different at all from the control group. So our interpretation here is that in anorexia, we have an altered body perception, right? And that's very specific for the own body. And there's this idea out there that they are maybe relying on like a wrong prior or wrong prediction. It's called the allocentric lock state. And the idea could be that basically if you have a wrong model of your own body, and then you touch yourself, of course, what will happen is that you will continuously produce a prediction error during self-touch. And of course, then this would show up as more activity in the brain because they have a failure to attenuate the somatosensory input, the expected sensation coming in. So basically, this part here, right? So if they expect here the body is bigger, and then they get the actual input, which feels different, like not that big as they predicted, of course, they will cause a prediction error. And then if this update over here doesn't work, then they might just be stuck in this situation here. So we find different profiles for ADHD, anorexia, and ASD. In ADHD, we find a larger self-other difference. In anorexia, we find a larger response to both self and other. And then in autism, we didn't find any evidence for altered self-other processing, but this has to be treated with a lot of care because, of course, in autism, it's very much known that people are very avoidant to touch or very aversive, and they don't like being touched. And so, of course, the patients or the participants that come to our study where we put them in an MRI scanner and we touch them on the arm where they can't move and they're forced in this bore, right? That will not be the people who are very touch avoidant. So it might just be a sampling bias, and it might just show us that there's quite a spectrum, and there are people with autism that don't show this touch avoidance and maybe don't have less of a self-other processing disturbance or alteration, but it doesn't mean that this is true for everybody. Now, at the very end, I want to just quickly show you some unpublished data from a study that we've just finished in anorexia, where we had 40 anorexia participants, and they came for one visit where, again, they did the touch task, and they also did some questionnaires, and our primary outcome was the body shape questionnaire. Then they were randomized to 3 groups, and one group was treatment as usual, and the other 2 groups did a body image training, where the idea was to, like, they would maybe call it body perception training. It's not so much about the image, but how they perceive their own body. And we combined this with active TMS or sham TMS to see if we can improve the effect of this training. And then they came back for another visit, and there was a follow-up after 6 months. We did the TMS, so this cranial magnetic stimulation, over the EBA, because there's some good support from the literature that the EBA is altered in anorexia. The EBA activates when we see pictures of bodies. We use an intermittent theta burst stimulation, which is considered to be excitatory. So you apply a magnetic field to the brain in certain pulses, and it's supposed to kind of cause a current in the brain, activating or deactivating the neurons in there, depending on the protocol that you're using. And we did this 5 times a week for 4 weeks, so it was very extensive. And our idea was that this would open a window of opportunity for updating the body perception, because afterwards they had 20 to 30 minutes of body perception training with a therapist. We did different tasks with them in this therapy session, where they, for example, they should choose a hula hoop ring, and then they should say, like, I choose the one that I think I can pass through, and then they would try that, and then the therapist would give them a different one, probably a smaller one, and be like, try this one, and then they would try that. They think that maybe they don't fit, and then they do fit, and then they have a discussion about this. There's one where they kind of paint the outline of their own, or draw the outline of their own body, a computer morph, psychoeducation about just the size of the skeleton that can't be smaller, and kind of a similar thing where they like measure kind of the circumference with like a piece of string of like different body parts and have a discussion about this with the therapist. So quickly to the results. We actually find that the TMS treatment improves the body perception disturbance in anorexia. So what you can see here is a body shape questionnaire, our primary outcome. And we find that in the group who did the active TMS combined with the body perception training, that they actually all showed an improvement at the 4 weeks, so directly after, and then a little additional improvement also after 6 months. The sham group shows kind of a bit of an initial dip, but then kind of goes back to their baseline. And the control group, they do actually, after 6 months, they're doing better. So the treatment as usual is apparently helpful, but it takes a lot longer. So after 4 weeks, the treatment as usual hasn't done that much yet. So it looks like our approach is actually doing something fast and also kind of substantial that kind of holds on even after 6 months. We then looked, they also did the self-other touch task, and we looked in the EBA what happened in these 2 different groups that received the sham and the active TMS. And we see that in the group that received the active TMS, that actually before the treatment, they had a response, a difference between self and other touch in the EBA that was different from the healthy controls, that you can see kind of a line here for the healthy controls, they averaged, and they improved kind of all of them in the same direction towards becoming more similar to the healthy controls. While the other group actually showed basically the opposite pattern. They all kind of showed a larger difference between self and other touch afterwards. So they might actually have used different strategies or not engaged the EBA in like kind of a good way, I would say, or like a useful way during this body perception training that they also did, which maybe caused them to show this opposite pattern. So our approach seems to work, but these were small samples, 10 in each group only, because we had this big treatment as usual group as well, so it's important to replicate this in a larger sample, but it's very consistent, so I'm still very excited about this. And with that, I'm at the end. I hope I convinced you that self-other distinction does form the basis for the bodily self, or maybe at least a basis for the bodily self, that it is crucially involved in several psychiatric conditions, and that it is an exciting avenue for novel interventions and treatments. And this is something that I will be exploring more in my new study that I'm running. That's my ERC funded study, where I will combine self-touch with psilocybin to see if it can support what I hypothesize, dysfunctional or altered sense of self in people who have lost somebody and developed prolonged grief disorder or complicated grief. And that's it. This is my great group. Reynard and Paula are the postdocs. Morgan and Adam are the PhD students. Johanna is the lab tech. They collected all this great data. And that's it. Thank you.